All right, so we're going to be taking a 2.2 kilowatt pump apart today, and a lot of you will recognize these. They come with some of your machines. This is actually a industrial blower, but it's commonly used as a vacuum pump also, where air comes in back here, comes into the turbine, and then goes out on that side. This is your bypass valve, and it's loose right now because I've done a little bit of work here so we can get this disassembled for you a little bit quicker and give you a look at all of the parts. So the first thing we're going to make sure that we do is make sure that you take the power off of this pump. Make sure that all the power cables are turned off and stored, and we'll go ahead and take the top off of the electrical box. And it's good to have a power driver. You'll hear that make some noise. That's a clutch system that's keeping me from stripping the screws out. These are really good tools. Of course, we're not sponsored by them, but this will help you a lot in the shop, and it has an adjustable clutch system on it. This happens to be one that you can turn into a drill style also, and then of course you can change the bits. So I would advise these a lot. We use them all the time. So we're going to take the top off of this panel and we'll get it out of the way. Make sure you don't lose your 4 screws there. One thing a lot of people don't really notice, there's some wiring diagrams underneath these. On most machinery you're going to find that there will be a wiring diagram underneath the top lid. We'll put this down here and get it out of the way. We'll talk a little bit about each piece as we take it off, just so you can identify what it is. Now, here is a capacitor. This has a lot of really angry pixies inside of it, i.e. electricity. It will get you if you don't discharge it, okay? So to discharge it, get you a decent screwdriver and touch the leads together. That'll discharge the capacitor, and we don't have to worry about it anymore. So we need to get that capacitor out of there first thing. The reason we're doing that is because we just don't want it flopping around and getting damaged. These capacitors sometimes will go out in case of an electric strike or a big thunderstorm. Sometimes you can lose those from time to time, and the diagnostic way to tell, or what really indicates that you're having a problem with it, is the motor will have a hard time starting, and you'll get a high amperage on start, because what that capacitor is really designed to do is it helps the motor come up to speed first, and then also it ensures that the motor turns the correct direction on every startup. Now, this is a designed for single phase 60 hertz power, which is what we have in North America, and then there's another little terminal in here which is marked with the ground plug. So there's your capacitor out. Put the capacitor on the end of the table. All right, so we're moving along here. We're going to go ahead and pull the bypass valve out. Now, I'm going to show the bypass valve to you pretty closely here. And the reason I want to show this is this single part will kill your pump faster than any other part here. Basically what this does is, when, let's say this is hooked to your table, you've got all your vacuum ports covered up, and this is getting its maximum amount of air coming through. A discussion to be had at some other time, but it's important to remember that these vacuum pumps actually provide a negative pressure, and ambient air pressure in the room is actually pushing down on the table. So when you starve this for air right here, and we can't get any cool air inside of this pump, it's just going to sit there and try to compress the same air over and over and over again and work against itself. And what will wind up happening, you notice that there's veins all over this. This is for conduction of heat. It's so that we can get the unit to cool down by passing air over it. Once this type of unit becomes heat soaked, and that means that we're no longer getting rid of the heat as fast as we're putting in it, you're going to start getting loss of performance real fast, and then you're going to start getting more amperage, and then more amperage means more heat, and it gets into a loop where eventually it just will destroy itself by overheating, or it'll pop a breaker because too much amperage. But on these, it is important to remember we send these out already set on this pump. Do not go back and set these. You need a special tool to know what you're doing with the flow and the pressure. This will burn your pump up if you try to adjust it. So we send them out adjusted. We suggest that you not modify this at all. We're going to turn the pump around, and we're going to pull the back housing off of the motor. Now, this is a AC induction motor, very common motor, very simple. These are really robust pumps. Don't have a lot of problems with them, and customers are really happy with them as a general rule. Now, one thing to remember is this pump is actually a blower. It's not built and dedicated as a vacuum system, but we use it for that, and it's used for that all over the world. It works really, really good for customers that don't have fixtures that they're trying to use all the time. And for somebody that's doing a lot of different projects, it moves a lot of air at a pretty decent pressure. So that really helps customers finish their projects, and you don't have to have a super expensive pump. These are really, really reasonable. We got a lock ring right here. We'll take that lock ring off. Always make sure you got some eye protection on when you're messing with lock rings. These things will, it's unbelievable that these can go about 5.5 miles when they pop off of the pliers, and they just have a way of getting underneath something where you will never find them again. In my home shop, I probably have 1,000 of them buried under everything. So what we're doing right now is we're pulling a cooling fan off. This is a plastic fan. I've had a lot of people say, well, why aren't you using a metal fan? You know, there's no advantage to one or the other, to be honest with you. Now, this fan is, you can tell that the vanes are straight up and down. That means that this is a bidirectional fan. It's designed to go either way. And it does a pretty good job in moving air across this pump in order to get the heat off of it. So we're going to take this. It's got a little keyway in it. Always remember, when you put this back together, you slide it into this keyway. Now, this is a good time. If you're pulling your pump apart, obviously you've had a problem, but this is a good time to feel that pump and see if you can still turn it. If you can turn this pump back here and you're having some other problem, it's probably electrical. But this pump, you can see the shaft has been beat on and everything else. This is a training pump that we use for letting customers see how to take it apart, training technicians and things like that. So we'll put our pump impeller up. Now we're going to flip this back around again, and we're going to go to the front side of the pump. And this is where sort of the cool stuff is that everybody wants to see. So this is the turbine housing. This is the back housing. This is the front housing here. Now, a word to the wise here is you're pulling this apart, pull these out first. There's going to be some small screws here. If you don't pull those out, I can guarantee you are not pulling this pump apart. It's not going to happen. There's a hidden bolt back here that locks it together. So we'll pull these out. Now, one thing to remember about these 3 screws right here is these 3 screws have a little special washer on it, and it also has O-rings on it. And you'll find that there's several places on this pump that have O-rings or seals, and that's because we're trying to hold that pressure in. So here we've got a little O-ring, and we have a domed washer that is designed to sit down inside of that. So these, you can normally just leave the O-ring on it. That'll retain your washer, and you don't have to worry about them. All right, we're going to move on to pulling the outer housing off This is the outer turbine housing. Sometimes you'll hear this driver, the clutching. Basically, we just don't want to strip anything. So we'll go ahead and pull these off. Now, there's no rhyme or reason to how I pull these out. When we put it back together, absolutely. We need to put it together in a special way, across from each other. So anybody that has any experience in dealing with engines or anything like that, you know, when you torque your heads down, you torque it in a specific manner because you want to make sure that you're getting an equal pressure on it. So these are coming out nicely. Okay. Those are out. Now we're going to pull this housing off here. Now sometimes it can be a little bit aggravating to get apart, and one thing that I've found is there's a little easier way sometimes to take these off, and that is to rotate that outer housing and just give it a tap with a hammer. And what's happening here, and you're going to see why it's being held, is there's a O-ring in here that's actually catching on a flange here. Now, I understand it looks like these was where those bolts are coming through, but they're actually not. They're coming through here. What these are designed for, this exact same pump is used with a dual impeller design, and it's a bigger motor obviously, but they use those in order to fix those impellers together. Now, interestingly, here you can see the chamber. So basically we're bringing in the fluid, which is air. We're pulling it into here, and you'll see we'll pull the actual turbine out in just a second. You can see as it spins it around here, it's going to build pressure and then dump it out of the backside. So nothing real special here. Just try not to mar up any of your finished surfaces, and be careful. This is sharp, especially this impeller right here. It is definitely sharp. One thing to look for if you are taking these apart for some reason is look for any kind of casting marks where a piece of casting could have let go. You want to look for any kind of long marks where that means that this pump may have ingested something. You may have some damage. Sometimes you'll get a vibration in these pumps, and that is very commonly because somebody has ingested something into the pump. So make sure, if you're going to run this pump, make sure that you got your filter in it. Make sure you're running the right filter in it. If you're trying to run a filter that is too tight, you're going to cause the motor to heat up. And also, if you have a filter that gets really dirty, what winds up happening is the pressure gets increased, and number one, the motor's working harder, but one part of the filter will fail, and when it does, it just basically tears a hole in it. Now all that debris has a way to come inside, so try not to do that. We're going to set this over to the side, and again, it's always good once you get done, spend some time and inspect your parts. So right now you can see I'm wiping off my table. What I'm doing that for is I'm just taking a look as I pull everything apart. I'm looking for any kind of debris or anything that might be coming out of this pump. Now we're going to take the center retaining bolt out. Now this bolt's normally a little tighter than that. Again, this is a training pump, but it's identical to the pumps that you'll get that are the 2.2s. Again, this is going to come out. It's got a concave washer that has a special shape for it that is designed to sit inside that bearing. So this bearing is being held onto the main shaft of the motor with this bolt, and then the outer housing goes around the bearing, and this is what causes this to float right now, and you'll see what I mean by that. Right this minute, this pump is not floating. It's not free. We can't turn it like we did a minute ago because It's very, very stiff, and that's because that rotor is laying right down inside of the stator of the motor. So we're going to get to that in just a minute. We'll take our bolt, we'll set it off to the side. Now we're going to pull our front bearing. Now this front bearing has a seal around it. It's a very important seal, and you can see, I'll grab it here, you can see where this front bearing will sit down in here and mate up perfectly. This causes the air not to be able to escape, and another reason for this is it will give you a little bit of vibration dampening on that rotor shaft. So it's a very important. Don't put this back together. If you tear the if you happen to tear the ring or you mess the bearing up, call us. We got them in stock. We can get them out to you very quickly. This is a very common bearing, so you can get them from us. You can get them off of Amazon. The O-rings a little harder to find, but we have them, so it's not a big deal. Now I'm going to put on my cool gloves. Only cool people can wear this type of glove right here. I'm doing this because this wheel will cut the immortal hell out of you, and I haven't had it say I'm sorry yet. Now sometimes when you pull this out, you can potentially pull that rotor out with it. That should not happen because there's a lock ring back there, but don't forget we've already pulled the lock ring and the fan out, so it's not a huge deal. You haven't tore anything up. It's okay. We'll go ahead and remove this impeller. Impeller's out. Again, guys, don't handle this barehanded. When I take this glove off, I'm going to show you why. There's part of my DNA stuck on that glove, stuck on that impeller right this second, to be honest with you. So it's already got me. If you notice, these are very, very sharp. And it's because it's moving inside this housing, and just the dust and any kind of debris that's in the air is used as it just sharpens it. So be careful. Inspect this impeller. This impeller is going to show what happened in the life of the machine. So all along these edges, and even you can see this one, it hasn't been run very much at all. But what we do, I've actually taken and dropped a bolt inside here and let people turn it to see what it feels like, how hard it actually locks up. On the back side of this, now remember, when you put this thing back together, on the back side is going to be your balancing holes right here, and that's what these are for. This gives you your dynamic balancing, so this thing's going to spin true. If any portion of these vanes or any of the fins get knocked off or get damaged, you're going to throw the bearing. You're going to throw the dampening effect of what these holes are doing, and you're going to lose a bearing at some point in time. So pay attention to that, okay? So we're going to go ahead and pull the keyway out also. Now, an interesting thing about the keyway, obviously, the keyway is locking our impeller to that shaft. But just a little tidbit of information, a lot of times keyways will be made with a softer metal than whatever it's attaching to, and a good example of that is like in a push lawnmower, they actually use a softer key so that when you hit something very hard on the ground, a root, a pipe, anything like that, that the flywheel doesn't explode and the engine just go to pieces. It'll actually shear that keyway and let that flywheel spin for a second. That takes all the energy out of it. So keyways are very, very important. Of course, most everybody has just found a piece of key stock somewhere and made one at some point in time. But in order for this machine to run like it's supposed to, make sure you use the stock keyway or get with us. We keep them in stock. All right, we're going to set that down. All right. Next along, we're going to turn the pump back around, and we're going to remove the back housing off of the motor. Back housing has 4 Allens on it. They're metric, so we're going to pull those out. All of these will be metric. Now this housing is retained by a bearing that sits in there. So sometimes this housing can be a little bit of work to take off. And if this one tends to be, I'll show you some tricks for working with that. Oh, no, we got it. Of course, the rotor's trying to pull out with it, but that's just not a big deal. Don't worry about it. One trick now, as we're pulling this back, obviously we're pulling the rotor out with that unit. But we want to be able to get that housing off, so there's a trick to doing that. We can just set this down right here, and we can just tap this rotor out of the housing. We didn't have to do that. You could pull it out backwards, but I have a reason for that. So we're going to pull the back housing off. Now, this is important. Pay attention. There's a hidden washer in here. This is called a thrust washer. This thrust washer gives preload to that rotor. It makes sure that the rotor stays pushed forward inside of the housing all the time. These are cast metal. They're just melted metal that's put into a casting, and then we put it into a machine, and you actually machine the surfaces that have to be precision. So all of this webbing is in there for strength purposes. Again, be careful, they can have sharp edges. Inside here, another O-ring. If you tear it up, there's a problem with it, call us, we keep them in stock. Make sure that you keep up with that ring. You need to put it back in when you get through rebuilding your pump. We'll set that to the side. So some very astute people would have heard something on the front side of this pump move. What you heard was this important washer. This washer right here is what maintains the distance in here from this flange to this bearing housing right here. So if you do not have that washer in there, you could put this pump back together, and you could potentially put the washer in front of this. If you did that, when you try to start this pump up, you're probably going to ruin the pump in a matter of seconds, because you're going to tear the fins off of it, or if you're really lucky, it's going to scare you half to death. You're going to turn the power off really quick, and you're going to say, well, I made a mistake. Let me go look and see what happened. Probably that washer got you. All right, we're going to pull the rotor out. We're going to do it from the back side. Rotor comes out, and this is a standard induction motor. Nothing really here you can do to it. So these are just iron cores that are actually made up of smaller cores that are glued together or epoxied together. And here is the inside of your stator. You can see electricity comes into here, creates a magnetic field, and that magnetic field causes this rotor to spin. So we want to look at this. Now we can tell that there's been some issues with this because it's been beat on. Really what should happen is this should go into a press to push this bearing. It's not a super tight fit, but we don't advise that you beat on it, obviously. And you want to inspect that shaft. You want to look for any damage, maybe any keyway damage, maybe where the keyway is slipped. You want to make sure that you don't have any damaged threads on it. But other than that, there's really no maintenance parts here, and they really don't go bad. Now, on to what does go bad right here. When you pull this pump apart and start inspecting it, you should see a little bit of shiny in here. These have laminate on them, so technically these wires are not touching each other conductively. This is has an epoxy on the outside of it. But as it heats up and after it gets heat soaked and after it gets hot and cool, eventually that epoxy will degrade and you'll wind up getting a short in a coil. At that point in time, you need to shut the unit down and you can send it back. We can take a look at it. Sometimes we can just replace the motor, but many times you've had so much use on it that it's just time to get a new pump. These pumps tend to last a really long time. So now what we're going to do is we're going to actually remove the motor from the front pump section. And in order to do that, we've got 4 bolts back here that we're going to pull out. Now, this section right here, this is the main body turbine housing. It has a seal in it that we need to be careful with. And that seal, when you pull that motor out, when you pull that rotor out, you need to be careful with that. And these are about the length of the bolt so you can see it. You can see there's a little bit of oil down here. There's nothing wrong with that. That is grease that's got hot and cooled and hot and cooled. And what it's doing is lubricating that seal back there in the back. So now we're going to pull we have all of the bolts out of that housing right now, out of the motor rotor, but it's not going to go anywhere yet. And that is because it is going to be retained by a bolt right down here. So that's going to keep that from wanting to come out. And of course we've had that loose already, so we'll go ahead and pull that out. We'll pull it out. There's going to be a flange in there, a little spacer, and you don't have to really worry about that spacer. That spacer just maintains distance. We'll go ahead and get the bolts out of the bottom of it here. Now, there is a little nut, a square nut that is being retained on these silencers right here, and I'll explain that to you in just a second. So you want to make sure after you pull these out that just take that nut and go ahead and put it back on that bolt. See this square nut right here? This square nut gets back into these retainers right here. So we're going to go ahead and get this nut out also. Put it back on. Keep these together. These are like that, those lock rings, they will disappear on you and you'll just never see them again. All right, so we're quickly running out of parts here to take apart. I'm going to go ahead and pull the silencers off right now. Notice that I said they're silencers. They're not filters. And it would be very, very easy to look at these and say, hey, this is a filter. It's not. Now, there is something special about this one. I'm going to show it to you before I take it off. If you notice, this has a piece of wire mesh in it. There's a seal behind this and a piece of wire mesh. Don't take that out and make sure you clean it from time to time. I've had people say, well, my pump is just not pumping. I think the pump's wore out. It's time for a rebuild. It's time to build a new one. It's time to buy a new one. It's just, you know, I can't understand why it's running so hot. Well, what happened is you probably ran it without the filter, or you turned the unit on, didn't even realize that you had cleaned the filter, just checking something, and you pulled a swallow of wood chips down in here, and you would be surprised how fast that'll get stopped up, and it'll completely ruin your pump. It'll just burn the pump up if you don't keep it clean. So make sure as part of your maintenance regimen that you want to clean that. Now this I'm just taking off to show you. We would have to take it off anyway in order to get the bolts out to disconnect the silencers from the rest of the body. But here's another one. This is basically the same. And these can be turned either way. It doesn't really matter. It depends upon your application and what you're doing with it at the time. So here we're going to pull the silencers. Now, why are these called silencers? Well, they're sort of like mufflers, really, but you would think that a pump like this creates constant pressure. It just does not do that. Every time one of these vanes, and I'm going to try to get it again so I don't cut myself to death. Anytime one of these vanes passes the outlet hole, it's going to cause an increase in pressure. And this turns a couple thousand RPM, so you've got to imagine you've got a constant series of wave pulses coming out of that outlet hole. And it causes a lot of noise. That it's in a pulse format or a wave format. So really what we've got in here is just a piece of foam and another piece of wire mesh. Now, believe it or not, this is designed this way. So everything in here is designed to catch that wave front, designed to catch that pulse and break it up. And then, of course, it'll go into the foam, and of course the foam will break it up also, so it makes it pretty quiet. These pumps tend to have a hissing noise to it. And normally what you're hearing is one of two things. You're either going to be hearing some kind of hole or gap that you have in your lines going into it, which means you need to check it. You know, like you probably know already, many of us, we run equipment with our ears, not with our eyes. So a lot of times you can just hear a piece of equipment and you know she's not happy. Something's going on, I need to check it. Do the exact same thing with this pump. So you will get a hissing noise out of this bypass valve. And what is causing that hissing noise is there's a valve in here that just goes up and down, that's spring loaded, and you'll hear that air coming past that unit. Some customers say they notice it, some customers say they don't. I don't really hear it that much, but I had some trauma to my ears in the military, so I really can't hear that. So we're going to go ahead and take this one off too. Same deal. This one's outgoing, one's incoming. Foam, just a piece of wire mesh. Now, you can't really put those on backwards because you're only going to go on the housing one way. Remember that we've got a seal. Now, you will hear from time to time, if you leave that out right there, now it will whistle. And it's trying to seal that up. You're pulling that air past it, and it'll really whistle. And it's hard to put this thing together with the clearances that it has without putting these back in there. So if you're a little conscientious when you do this, you're not going to have an issue with it. Now what we've got left is the rotor and the main body housing. And there's actually a pretty precision fit on this housing. So we'll have to tap it. We do a little hammer massage on it. And we have pulled that body off. So you can see that there's some machine surfaces that have to line back up. Once again, we've got a seal in here. If you've had to go this far, you've had to take it down, at least check the seal. We advise you to change it if you've had to pull this unit apart. But if there's no damage to it, there's no need to spend the money. But any damage at all, they're not very expensive. We keep them in stock. You can get the number off of it. You probably buy it on Amazon. Put a little grease back on it when you put it back in. Be careful with these flanges. They are sharp. And make sure when you put this thing back together, take your time. Don't jam it together. If something feels like it's not going right, just stop and look. If you're really in a bind, just give us a call. We'll help you with it. Exact same side here. Now this housing, we want to look for a couple things, especially down around these lips right here. These lips are extremely sharp. And you will see marks. If anything has come inside this housing, you're going to see it. Now, one thing you can look at here is called casting flashing. So basically, when this was poured, this is where the casting material spun going in there or hit a wall and bounced back as molten metal, and it will leave some casting material, and you can see it looks like this has been scratched. What that actually is where somebody has come in here and cleaned that casting material off. And we do see from time to time that if it is not done correctly, some of that will break off and could potentially hit your compressor. We check all of these that come out of our factory, so you don't have to worry about that. And pretty lightweight unit. You won't have a lot of problem with this unless you drop the unit. All right, now we're down to the motor itself. The motor itself is going to be your heaviest part, obviously. Again, what we're looking for is any kind of damage or heat. Now, these will change colors over their lifespans, and these motors absolutely have a lifespan, right? Because they are just living one of the worst lives. Constantly heating up, constantly cooling down, and it eventually will cook this, and it will cook these strings. These are actually just strings that holds this together. So now that we've got a better ability, we can flip this over and we get a little view into here, and you see our grounding lug. So there's really no more disassembly that you can do to this unit. Anything that could be fixed or put back together, we've already taken off of this. If you're having a problem with the main motor here, many times it's just as cheap to just call us, let us get you a body or help you into another pump than it is to take this and have it rewired. But you know, some customers just they like to continuously keep something going. There's certainly nothing wrong with that. At a later point in time, we'll do a video on showing you how to diagnose this, how to check the leads, what we're going to do with a multimeter to do that to see if we've got a short. But other than that, I think we've pretty much covered everything. Again, if you have any issues at all with your pump or you have questions or something we can help you out with, go and check phantomcncsystems.com and look at our help section, or look at the number and just give us a call. Our technicians are there every day, and we're here to try to help you and make sure we can keep you up and going. So again, thank you for your time, and I appreciate you living through this video with me.